All right. Thank you, Professor Lina Quan, for joining us. Lina is a faculty member at Virginia Tech in the chemistry department. And I'm also joined by Dr. Rang Shah, a new postdoctoral fellow at Northwestern University. I'll start with the first question for you, Lina. Can you say just a bit about the work that you did when you were at the University of Toronto as a doctoral student? What was the research that you were most proud of?
I'll say when I joined the Sargent group was back in 2014. I was a visiting student that was fascinated by the newly emerged semiconductor halide perovskites. And back in 2014, it was a really early stage of the perovskite P field that being developed. And when everyone was trying to make the perovskite solar cell with higher efficiency. And as the efficiency was quite low compared with what we have seen right now in the chart. So at that time, me and my mentors, who were a couple of senior postdocs in the group at that time, we worked together and tried to address one of the challenging problems, which was the instability of the perovskite materials. Although they showed a very promising photovoltaic efficiency, but if we have a really bad stability, then it's impossible to be commercialized. So we address those challenges by introducing those low-dimensional perovskites to protect those perovskites that against to the moisture. So what we did, we introduced some of the organic ligands to the bulk perovskite materials, so they improve their efficiency as well, and also maintain their high stability as we had in the low-dimensional perovskites. And in the meantime, I found exciting photophysical phenomena from those dimensional perovskites. So when I'm making those perovskites for solar cell application, and I routinely measure the luminescence property as a kind of routine measurements. And what I interestingly found was the material that has a lower dimensionality have a really high luminescence property in the meantime. So we were really interested in what is going on in the material, and me and one of my colleagues in the group, we used ultra-fast palm probe spectroscopy to investigate the origin of the photophysical phenomena that leads to the exciting luminescence property. So, and to switch my research project into the luminescence and light-emitting diode applications, so that I had a couple of follow-up works on how do we develop a high emission, high efficiency, and stable perovskite light-emitting diode device. So looking back, I think I was really incredibly lucky to have my mentors in the group. And without their helps, I don't think I achieved all those research accomplishments during the time that I stayed in the group.
Thank you, Lina. Now that you're Professor Lina, can you tell us what you're up to now? What's the research that's going on in your group at Virginia Tech?
Sure. Our group envisioning the optical and electrical properties from those emerging semiconductor material, such as perovskite and perovskite-derived relevant material system. So we control and manipulate the light-matter interactions for the relevant technological advance. So we employ a number of cutting-edge characterization techniques, for example, the palm probe ultrafast spectroscopy, and also we actively use the synchrotron X-ray source, such as Argonne National Lab and also Lawrenceburg National Lab, to study the photophysics and structural relationship of the materials and devices within the high spatial and temporal resolution. So we basically investigate the structural and property relationship from newly developed material system. So our work can find a number of applications, including renewable energy applications, such as photovoltaics and hydrogen generation, and also light emission devices.
Can I add one more question?
Sure.
So in your first few years as a junior faculty, you should stick on what you are familiar, or you should try something totally new.
Yes.
That it probably broader impact, but high risk, high return, I will say.
In my current group, we have both high risk and low risk project. Because if I stick to the high risk, the risk and those challenges to students is too high. So that sometimes I will assign 2 different projects to students that have a long term that has high risk, but as a short term, students can also accomplish low risk, but also some creative research project. In that way, students will also have some accomplishment at the end of their PhD study. But at the same time, if they success with those high-risk projects, then they will also create some new fields in those material science, I would say.
I have maybe a last question about networking. Can you say anything about the importance of developing mentors or developing relationships that go beyond just your PhD and your postdoc group, even when you're a PhD student or a postdoc?
Yeah, I think networking is truly important, not only for the job searching process, but also after become an individual PI. I always need those networking to consult with people in the field and also to discuss the research project that being developed in my group with those well-known professors in the field. So my strategy is, as a PhD student, of course, Professor Ted Sargent and Professor Peidong Yang provide tremendous opportunity to host those visitors and give me a chance to interact with those visitors so that I had chance to have lunch with them, to have dinner with them, and I had a individual conversation with them. But most importantly, as a independent PI, I think by attending the conference to communicate with people in different field and within my field is very important. The communication skill is one of the important part of the skills that establish the good network. And also by organizing the symposium in the big conference is also one of the very important skills I think should have to establish the wider network community so that to bring up the visibility of myself in the community.